Okay students, welcome back to the naive-based classifier part 2, where we'll try to solve a example, and by solving the example we expect that you have a clarity of implementation. So let's say this is an data set given to you. We have email IDs, numbers, and in an email ID means email you contain free, no, yes, no, yes, no, yes, no, yes, no, yes, no. So the word free is present in 10 emails, and if it is present then it is yes, no, yes, no. If you have offers, then if you have yes and no, yes, no. That is, a word offer is present in that email. Now the classification says yes, if both free and offer is present, this is a spam email. No, yes, no, yes, no, yes, 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 no, 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 yes is again no, yes, no is yes, yes, yes is yes, and no, no is no. So this is how the reading of interpretation of data set is. So and this is the classification. Okay, so that is yes and no. So every data set is between yes and no. Okay. Now what we'll do, we'll compute the prior probabilities. The prior probability of spam is that out of total 10 spams in the data set, 6 were spams. So that becomes 0.6. And not spam, that is 1 minus 0.6 or 4 upon 10 is 0.4. So this is the prior probability. Now, what do? You compute the likelihoods. The likelihoods are computed upon free spam. The word free is present in the classified where we have a spam, and offer is present where we have spam. So emails with free spam, free in the spam is 5.6. Okay, and total email was 6, so that computes to 0.833. Okay, and offer spam is 4 upon 6, that is computes to 0.667. For not spam email, okay, so what you can do? Email with free in not spam was 0, so it is 4. Total not spam email were 4. Offer not spam, emails with offer in not spam is 2 upon 4, that is 0.5. So we have calculated the likelihoods. So free spam, sorry, let me go back. So free spam, offer spam, free not spam, free offer not spam. So these are the emails that were classified as spam, which had the word free. Spam was classified with the word offer. Free was classified but they were not spam. Offer was present but they were not spam. So this is the statistics you get from the data set. Okay. So we use the Bayes formula to compute spam x. So what do? X is spam multiplied by probability of spam by probability of x. So we had already did all kinds of computation. So ignoring p of x, because p of x would be same for every class. So spam of x is proportional to probability of spam, free spam multiplied by p offer spam. So that computes to 0.33. And not spam x, so if you have not spam, free not spam, offer not spam, so that computes to 0 because free not spam was 0. Okay, so now since the p spam x with the value is what? P spam x is 0.33 and p not spam is 0. So naive Bayes classifier predicts it's a spam. Simple application. So advantages of naive Bayes: fast and scalable, it works very fast. We can apply it on the large values, handles the missing data, can still make predictions even if some features are missing, that is, you can remove the rows, it works fine. Works well with small data set also. Unlike deep learning, doesn't require a lot of data. Performs well in text classification. Mostly we can use in text classification. Limitations of naive Bayes: strong independence assumption, and I've told you at the beginning also that features are related. X1 feature is related to X2. That I give you the example of height is directly proportional to weight, but it's not absolute truth. Okay, but most of the time it is true. So zero probability problem: if features never appears in the training set for a class, its probability becomes zero. That is a very bad thing. Solution is we can use Laplace smoothing. Okay, we will give some value, some number to that. We will not assume absolute zero for that feature. Okay, that is count xy plus 1 divided by count y plus k, where k is the number of possible feature values. Conclusion: naive Bayes is simple, efficient, and works well in many applications. It is optimal under the conditional independence assumption, but may fail when features are highly correlated. Despite its simplicity, it is often competitive with more complex models like SVMs and deep learning for text classification tasks. That is, most of the text classification you can do it with this naive Bayes. Thank you all. This ends the naive Bayes.